kinematics, this time focusing on trigonometry. So here we have a question cut straight from the book that is looking at particle P that moves along the x-axis given by position xt equals 1 take 2 cos t. Xt in our case being a displacement function. So you can think of it as st, which is what we've been talking about before. Same sort of thing. Alright, state the initial position, velocity, and acceleration. Alright, so what we need to do is we need to find, first of all, the velocity function and the acceleration function. So the velocity function is the differentiation of the first one, which is going to be positive 2 sine t, and the acceleration function is the differentiation of that, which is minus 2 cos t. Alright, now we need to find VO and AO, and also we need to find SO, or XO in this case, because they are our initial conditions. So XO is 1, because when, let's think that through. When t is 0, cos of 0 is equal to 1, minus 2 lots of 1 is minus 2, 1 minus 2 is minus 1. So it starts 1 meter to the left of the origin. Then velocity. Velocity is 0 into here, which means we let t equal 0. Sine of 0 is 0, 2 lots of 0 is 0. It's not moving, so there's 0 velocity. Here, sine of t, cos of t, cos of 0 is 1, minus 2 times 1 is minus 2. So our initial conditions are 1 meter left of origin, 0 meters per second squared velocity, so at still, it's standing still, minus 2 meters per second squared is accelerating at 2 meters per second away from the origin further to the left. So you have a mental picture of where this point is on your head, where it's moving and where it's accelerating towards. Alright, describe the motion at time equals pi on 4 seconds. Well, very simply we need to do the acceleration and velocity at time equals pi on 4. So here, velocity of pi on 4 is 2 sine pi on 4. Now sine of pi on 4 is 2 on root 2. I lied. It's root 2 on 2 times 2 is just equal to root 2. And acceleration of pi on 4 is equal to, well, minus 2 lots of root 2 on 2 is minus root 2. Right. Meters per second squared. Find the times when the particle reverses direction and find the position of those at those instances. Alright, see over here. It reverses direction when the velocity is equal to 0. So we're looking for times when the velocity, Vt, is equal to 0. Or where 2 sine t is equal to 0. Now 2 sine t is equal to 0, we're only looking for between 0 and 2 pi. And if you think about the unit circle, well, sine t is equal to 0 here and here. So our two solutions for t are 0 and pi. Alright. So, two solutions for t, 0 and pi. Easy enough. We know it reverses direction, therefore, at 0 and pi, and now we want to find the position of the article at those instants. So the position is to sub 0 and pi into the original function, into our xt function. So that is 1 take 2 cos 0 and x pi. It shouldn't be t, it should be 0. Equals 1 take 2 cos pi. Alright, cos of 0 is 1, so that becomes minus 1. Cos of pi is minus 1, so that becomes 3. So if we're thinking about where this particle reverses direction, it starts 1 meter to the left, and at that point it's at rest and effectively reverses direction, and therefore it also reverses it, and it reverses at 3 when it's 3 meters to the right of the origin. Alright. Find the particle's when the particle's speed is increasing. Now this is slightly complicated in that we can have an increasing speed in either direction. So speed is subtly different to velocity. Velocity is both positive and negative, meaning you have a negative velocity, positive velocity. Speed is always positive. It is the magnitude of velocity. So we will be increasing with speed if our velocity, if Vt is less than 0, and At is also less than 0, then we're accelerating and increasing our speed towards the left. Or, if Vt is positive and At is positive, then we are increasing our speed and accelerating towards the right. So we are looking for times when these conditions are met, when the signs are similar. So the best thing to do is draw a sign diagram of each. So the sign diagram of velocity looks like this. At time equals 0, it's 0, and at time equals, we saw up here, pi. Right. And we need to figure out whether a positive and negative between that. So really, we can't think about before 0, because nothing happened before time 0. But let's see what happens after these two, and we're ending here at 2 pi. Alright, so what we can do is we can sub in a value of, say, pi on 2, or pi on 6, or some small value of pi to the velocity function. So here, that's velocity. If I sub in pi on 6, I know that sine of pi on 6 is a half. 2 times a half is positive 1. So it's positive here. Now we can't assume a sign change here, but let's just see what happens. If we sub in a value of greater than pi, well, if you think about round the circle here, greater than pi is everything on this side. Sign is negative there. 2 times a negative is a negative. So that there is the sign diagram for velocity. Now for At. Sign diagram for At. Well, At is just minus 2 cos t. And that there is equal to 0 when t is equal to either pi on 2 or 3 pi on 2. And I hope you're happy there, but cos is equal to 0 up here and here. So therefore we are equal to 0 at pi on 2, 3 pi on 2. Now, let's think about the sign of cosine. And we're going between 0 and 2 pi. The sign of cosine here is positive. So between 0 and pi on 2, it's positive. Between there and there, it's negative and positive. And we want to look where the signs line up with each other. So we can see that here, both of them have the same sign. Therefore, the speed is increasing, because they're both positive. And here, both of them have the same sign, so it is increasing. So we can say that the speed is increasing between 0 to pi on 2, and it is increasing but in a negative direction, so that still the speed is increasing between pi and 3 pi on 2. And you'd write that out more mathematically than I have, but right now for the video I think it's important for you to know that the speed of an object will increase when these line up and this line up. If the signs are different, that means it's either going this way but getting slower, or going this way but getting slower. So decelerating, and the acceleration is working against the velocity. Alright, we will do another practice in class, I hope, if we get time. If not, there'll be plenty of practice questions to go through. Essentially, it's just an application of differentiation. It's being able to differentiate repeatedly, and then understand what it means at those stationary points, where things are equal to 0. Alright, thank you very much.